in this lecture, we consider an application of a theorem called Internal Angle Bisector Theorem from the geometry, and a question which appeared in the JEE Main exam held on 29th January 2024 in shift 1 is an application of this theorem. And this theorem normally, it's a very rare theorem that appears in the examinations. So it's an unexpected theorem. Let's now first of all see what is this theorem and what is this question that is given in the JEE Main examination. First of all, let's talk about Internal Angle Bisector Theorem. This theorem states the internal bisector of an angle of a triangle divides the opposite side internally in the ratio of the corresponding sides containing the angle. So here is the triangle A, B, C, and we consider the internal bisector of the angle B. So this is the internal alpha alpha, same angle. It is bisecting the angle B. And the angular bisector is dividing AC at a point D. Then it says BA by BC, that is the sides containing the angle B, is in the ratio of AD is to CD. So the internal bisector of an angle of a triangle divides the opposite side. So opposite side internally in the ratio AD is to CD is in the ratio of the corresponding sides containing the angle. The corresponding sides containing the angle is BA, BC. These are the sides containing the angle B. So it is an important theorem, and which appears very rarely in the examinations. Right. So what is that question that has come in the JEE Main exam held on 29th January 2024 in the first shift? The question is, in a triangle ABC, suppose y is equal to x is the equation of the bisector of angle B, and the equation of the side AC is 2x minus y is equal to 2. If 2 times AB is equal to BC and the points A and B are respectively the ordered pairs 4, 6 and alpha, beta, then alpha plus 2 beta is equal to, we are given 4 options. So read the question carefully. We have a triangle and it is given y is equal to x is the equation of the angular bisector of B, and is also given the equation of the side AC as 2x minus y is equal to 2 and 2AB is equal to BC. That is, you can think of a ratio here, and the points A and B are respectively given as 4, 6 and alpha, beta. Then required to find the value of alpha plus 2 beta. Right. That's our question. Let's now discuss the solution of the problem in detail. We have the triangle ABC. Let's look at the picture, the diagram ABC. Right. And in this, the points A and B are respectively given as 4, 6 and alpha, beta. So the points A and B are respectively given as 4, 6 and and alpha beta as B as alpha comma beta. Agreed. Now what is further given? Given y is equal to x is the equation of the bisector of the angle B, and 2x minus y is equal to 2 is the equation of AC. So the angle bisector of B is y is equal to x, and the equation of AC is 2x minus y is equal to 2. Let D be the point of intersection of y is equal to x, that is the angular bisector, and the AC. D is somewhere here, and this is the angle bisector B. So alpha the bisecting the angle, and that is y is equal to x, the angle bisector, and D is the point of intersection of y is equal to x, and AC. And it is given the equation of AC as y is equal to 2x minus 2. Right. Now let us take the coordinates of C. As h comma 2h minus 2, because it is lying on the line AC, whose equation is y is equal to 2x minus 2. Agreed. Now given 2AB is equal to BC, and this is 1 by 2 is equal to BA by BC. Now what is BA by BC? Use the angular bisector theorem. Angular bisector theorem says BA by BC will be AD is to CD by angular bisector. That means AD is to CD is also 1 by 2. That means D divides AC in the ratio 1 is to 2. D divides AC internally in the ratio 1 is to 2. And we know the coordinates of A 4, 6, and the coordinates of C is h comma 2h minus 2, and the D is dividing AC in the internally in the ratio 1 is to 2. Therefore you can find the coordinates of D. So the coordinates of D are given by the section formula you apply: 1 times h plus 2 times 4 by 1 plus 2, that is the x coordinate, and 1 times the y coordinate of C, that is 2h minus 2, plus 2 times 6 by 1 plus 2, that is when simplified it will be the ordered pair h plus 8 by 3 comma 2h plus 10 by 3. And you can now use these are equal. Why? D lies on the angular bisector of the angle B, whose equation is y is equal to x. Therefore they are equal. When equated you will get 3 cancels, and this will be 2h minus h is h is equal to 8 minus 10, that is minus 2. So h is equal to minus 2. We continue in the next slide. Right, that is the picture diagram what we have, and we have seen in the last slide that h is equal to minus 2. Now when h is minus 2, the coordinates of C we have given. What are the coordinates of C? H comma 2h minus 2. So in that h is equal to minus 2 we got it, and now substitute h is equal to minus 2 in this, you will get minus 2 comma minus 6. So now we got the coordinates of minus 2 comma minus 6. So far everything is okay, and we have used that internal angular bisector theorem also. But now the coordinates of B are given to be alpha comma beta, and required to find alpha plus 2 beta. How to find? It's again we will use this the angular bisector theorem of angular bisector of the angle B is y is equal to x. That fact you use, and 2 times AB is equal to BC. That fact you use. And using these two facts, what you can see is you can find the images of the points on BA as the points on BC in the line y is equal to x. That means in the line y is equal to x, y is equal to x is the angular bisector of the angle B, and 2AB is equal to BC. That means AB has less length than BC. Then you can find the images of the points of BA seen in the line y is equal to x as points on BC. So now, since BD is y is equal to x is the internal angular bisector of B, the images of the points BA with respect to the line y is equal to x will lie on BC. Now, because 2 times AB is equal to BC, you can see the image of A in the line y is equal to x as some point on BC. And let's call that point as A prime. Let A prime be the image of A whose coordinates are 4, 6 with respect to the line y is equal to x will be some A prime that lies on BC whose coordinates are 6, 4. How 6, 4? Because you are seeing that the image of 4, 6 in y is equal to x. Therefore, the x and y coordinates will get interchanged. So 6, 4, 6 image is 6, 4. It is somewhere on BC, and that is A prime. So this is A prime. Why somewhere on the BC? Somewhere, because 2 times AB is equal to BC. That is the reason. That's the reason. So this is the point A prime. Now things are now very clear. Now I will find out the equation of BC. What is the equation of BC? Is none other than the equation of A prime and C. We will write down the equation of A prime C using the 2-point formula and use the fact that equation is the same as the equation of BC, and it is passing through alpha comma beta. Therefore, you will get a relationship between alpha and beta. Then we can find out alpha and beta and find out alpha plus 2 beta. So look at the application of the angular bisector theorem, internal angular bisector theorem, once again we now write down the equation of BC. The equation of BC is same as the equation of A prime C, and the coordinates of A prime 6, 4, and the coordinates of C -2, -6 are known. Therefore, you can write down the equation of A prime C using the 2-point form of the straight line. And that we first of all do that. The equation of BC is same as the equation of A prime C. And the equation of A prime C is given by y minus 4 is equal to y2 minus y1 minus 6 minus 4 by minus 2 minus 6 multiplied by x minus 6. And when simplified, you will get 5x minus 4y is equal to 14. Now it is the equation of A prime C, which is the same as the equation of BC, and this line is passing through B, whose coordinates are alpha comma beta. Therefore, alpha comma beta also satisfies this equation. Therefore, you get a relationship between alpha and beta, and put x is equal to alpha, y is equal to beta in this. You get 5 alpha minus 4 beta is equal to 14. But now this alpha comma beta lies on the angular bisector of the angle B, and whose equation is y is equal to x. Therefore, alpha is equal to beta. So now beta is equal to alpha, since B whose coordinates are alpha comma beta lies on the angular bisector whose equation is y is equal to x. Therefore, you substitute 5 alpha minus 4 beta is equal to 14, beta is equal to alpha. Then you will get 5 alpha minus 4 alpha is equal to 14. That will give you alpha is equal to beta is equal to 14. So 5 alpha minus 4 alpha is alpha. Alpha is equal to 14, but alpha is equal to beta. So now we got the values of alpha, beta, and we compute alpha plus 2 beta. So what is required is alpha plus 2 beta is equal to alpha plus 2 times alpha, that is 3 alpha, 3 into 14, that is 42. That is the answer to this question, and this answer 42 appears against option 2. Therefore, the answer to this question is option 2. And it is a very interesting question, and which uses a very important theorem called the Internal Angle Bisector Theorem. And this question comes out to be an application of this theorem. And this theorem is very rarely used in the JEE examinations. And this question has appeared in the JEE Main exam held on 29 January 2024 in the first shift, which uses this theorem. Right. So I am sure that you have understood the solution of this problem, and you appreciate the application of the internal angle bisector theorem and its application. Please concentrate on this theorem. There is a possibility that it may be used in some other example, in some other examination. So I wish you all the best. Thank you.